Hey Math Kids, today we're going to talk about finite geometric series, and we are in section 5H in your book. We will start with example 28 after we talk about a few things. So like the title suggests, let's see, finite. We are only focusing on finite series in this video, and we have two versions that we can use, but they're essentially the same thing. You can use either one in the same situation as the other one. So if you're trying to memorize this, just don't worry about, actually that's the one I like though. I personally like the second one better, but it really doesn't matter which one you use. So like I said, they're the same thing. Now if we go to example 28, it says find the sum of 2 plus 6 plus 18 plus 54 plus ... and it wants us to go to 12 terms. So we use our equation here. We're trying to find the sum out to 12 terms. And then we have our first term, which is 2. And then we have r, which is our common ratio. So we have to think, what are we multiplying by to go? Well, it looks like 3. 2 times 3 gives us 6. 6 times 3 is 18. And so our r is equal to 3. So we get 3 raised to the n was 12. And then we have 1 minus 3. Okay, we do some simplification. So this and this will cancel and leave a negative, because this is really just -2. Cancel, we'll bring the negative up top. 1 minus 3 to the 12, like that. And I am just going to use a calculator for this. So let me pull this up. Bring this out. So I'm just going to do parenthesis. Oops. I'm going to say negative sign, parenthesis, 1 minus 3 raised to the 12. And we get a pretty big number. So we get 531,440. So if we added this, the first 12 terms of that sequence, so that makes it a series, if we added it just to 12 terms, we'd already get this high. So we see how fast that one is growing. Okay, now we're moving on to example 29. Find a formula for Sn, the sum of the first n terms of the series 9 minus 3 plus 1 minus 1/3 plus ... So I'm going to just write our S sub n formula down, or one of them. You could use either one. We're going to plug in some values for this. So u1 is our first term, so that's 9. Now we want to figure out our common difference, so we're definitely decreasing as far as the magnitude goes for each one. So 9, 3, 1, 1/3. And so our r is going to be 1/3 because we're dividing by 3. However, because the signs are flipping, positive, negative, it's actually a negative 1/3. And then we're going to raise that to the n, this n, all over 1 minus a negative 1/3. Okay. So this is a general formula. Technically this would work, but we can make it look a little bit nicer. So right here is really adding. So I'm going to do a couple things. I'm going to change this to have a common denominator. So I'm going to say 3/3 plus 1/3. So the entire bottom becomes 4/3. Still have our 9 out in front. 1 minus a negative 1/3 raised to the n. Now, we can't do anything about these two negatives because with PEMDAS, exponents come before multiplication is technically what we would be doing there. And so we'd have to apply the n before we could worry about these. And so unfortunately we just have to keep that weird looking double negative thing going on. Now, what we can do though is we can combine this 9 and this 4/3. And so if I want to bring this 4/3 up top, I just think of it as a reciprocal. So in other words, I can multiply the bottom by 3/4 and the top by 3/4. Cancels the bottom. Top, 3 times 9 is 27/4. And then 1 minus negative 1/3 raised to the n. And that would be our S sub n. That would be our general series formula for this series. Okay, we're moving on to example 30. And it says a geometric sequence has first term 5, common ratio of 2, the sum of the first n terms of the sequence is 635. Okay. So we can set it up. We can do this one by hand if we want. So Sn is u1 r to the n. So I'm just going to use the other formula so you can see that it really is the same thing. If you use the version of this formula that we did on the previous problem, that's fine. It'll work out the same way. So we plug in what we know. So we have 635 for our S sub n. Our u1 is 5. Our common ratio is 2. We don't know n, but we know r again. Now it just comes down to simplification. So the bottom just becomes a 1, so that ends up being redundant. So we can just focus on the top now. So it was like that, but we don't have to worry about if the bottom of a fraction is a 1, we can just get rid of it. Okay, let's distribute. 5 times 2 to the n minus 5 equals 635. Add 5, 640. Divide by 5, divide by 5, so 640, I don't know why this isn't responding, hold on. Okay, 640 divided by 5, 128. So we get 128 equals 2 to the n. And we haven't learned how to do this by hand yet. We haven't talked about logarithms. So I'm going to do it with this calculator. So I'm going to graph both sides, 128, as well as 2 to the n, or 2 to the x in this case, same thing. Graph it. I need to change my window. It's not going to show up the spot that we want. So I need to go up high enough on the y-axis to see 128. So I'm going to change my y max to 135. Graph it. So there's my 128 line. It's going to graph my 2 to the x line. And they cross right there. So we're going to go second, calc, go to the intersect. It's going to say first curve, second curve. So you can just click, because there's only 2 curves on there. And then you want to make your guess as close as possible. It only crosses one place, so you actually could have just clicked again. But, okay, we're close there. Okay, so it says it intersects at x equals 7. And so that is the answer for our n. So n equals 7. Okay, and that is everything for this video. If you need additional help, come to Math Lab, and until then, calculator.